We're going to start our discussion today on relative motion by looking at these two particles, A and B. So these are independent objects. They're not the same particle. They are totally separate. So we want to look at the motion of one relative to the other. So we've already defined a coordinate system xy, and we're going to look at the absolute position, which are shown by these vectors here. So we're going to call this one RA and RB. So we can put a local coordinate system on a particle, and that would look like this. So we would have an xy coming off of this A particle itself. So this coordinate system is going to move with the particle. And now that we have that, we can start looking at relative motion. So we can measure the position of particle B relative to particle A by using a vector that'll look like this. And we're going to call this vector R B/A. So this gives us a vector triangle, and let's start writing some of this out. So we can say RB equals RA plus RB relative to A. So that's how you read this. So that would be, anytime you see a B/A, that would mean B relative to A. And now we can, of course, take the derivative of this position to get the velocity. So velocity is going to be equal to d over dt RB plus, we want to say our velocity is going to be d over dt of RB relative to A. And we can simplify that by just saying velocity B equals velocity of A plus the velocity of B relative to A. Just like we can say above, the position of B equals position of A plus position of B relative to A. And of course, for acceleration, we can take the derivative of our velocity with respect to V. So velocity of A plus derivative of velocity of B relative to A. And shorthand, we can say acceleration of B equals the acceleration of A plus the acceleration of B relative to A. So now that we know this, the best way I think to look at these kind of problems, because they can be a little bit confusing when you're looking at multiple different particles and objects and you're looking at relative motion, is to look at an example. So let's pull one up. Two cyclists A and B travel at the same constant speed v. Determine the speed of A with respect to B if A travels along the circular track while B travels along the diameter of the circle. So we know that our expression for velocity, A relative to B, that's going to be VA minus VB. So let's look at these A and B velocities. So VB, this one is going to be pretty simple. So B is traveling just horizontally back and forth the diameter of the circle. And we know that it's traveling at this unspecified speed of V. So it's going to have an I component but no J component because it's not moving up or down, just horizontal. So we can say the velocity of B is going to be the speed times our I unit vector. So in our velocity of A, we know that we're looking at something like this. So A is up here. Here's our angle theta. So this would be V cosine of theta and V sine of theta. So those are going to be our I and J components of our velocity for A. So let's write that in. So V sine of theta I plus V cosine of theta J. So our velocity of A relative to B is going to be equal to this VA minus VB. So VA sine of theta I plus V cosine of theta J minus VI. So just doing some algebra, grouping that together, is going to be equal to this expression here. And that'll give us V of A relative to B. So this is our velocity, but they want to know the speed. So we want to know the speed of A with respect to B. So as with any vector, to know the magnitude, we're going to take the square root of the sum of the squares of our components. So V of A relative to B for the speed, that's going to give us V times sine theta minus V squared plus V cosine of theta squared. So the square root of the sum of the squares, and this is going to work out to give us V times the square root of 2 times 1 minus sine of theta. So the magnitude of V A relative to B, or the speed, is going to be equal to this expression here. And that is our final answer. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.